What's up, Algebra 1 students? This is Lesson 33. Our objective for today is how do you find the probability of independent and dependent events? So the first thing we need to do is, what is an independent and a dependent event? Well, an independent event, think about if you're being independent, then you can make your own decisions. It's not based on what other people want. So the definition of an independent event is the outcome of the first event does not affect the outcome of the second event. And if we want to calculate that probability, you just find the probability of the first one and you multiply it by the probability of the second one. Dependent events, if you're dependent on someone, that means you rely on what they're going to do. The outcome of the first event does affect the outcome of the second event. And if you want to calculate that one, again, you just multiply them, but you have to calculate the second one based on what's already happened in the first one. So let's just try real quick identifying events as either independent, where they don't affect each other, or dependent, where they do affect each other. So part A here says tossing 2 coins, a dime and a quarter. Well, if I'm just going to toss 2 coins, whatever the dime does is not going to affect the quarter, and whatever the quarter does is not going to affect the dime. So they do not affect each other, which means that these would be independent. Tossing the same coin twice. Well, if I toss the coin once, it's not going to affect how I toss it again. So it's going to be independent as well. Number C. Putting 10 students' names into a hat and drawing 2 names without replacing them. So like going to be 2 people are going to get to go to recess first or something. So you would put everybody's names in a hat and you pull out the first one and you pull out the second one. Well, if you think about it, the first one has a 1 in 10 chance of being picked because there's 10 names in there. Whereas the second one has a 1 in 9 chance because one of the names has already been pulled out. So this one would be a dependent event. And part D, putting 10 students' names in a hat and choosing one each week for a room monitor. A student may be picked more than once. So it says everybody's name is in a hat, so you just reach in, you pull one out, and you're like, oh, Johnny's going to be room monitor today. And then you put it back in there, back in the hat. And then next week, you'd pull a name out again. Well, Johnny might be picked next week too. So notice, next week's pull will not affect this one. So this is going to be an independent event. Alright, this is like example 3. It says a bag has 5 $10 bills and 15 $1 bills. What is the probability of drawing a $1 bill, then a $10 bill? So I guess the first thing we need to do is we need to figure out how many bills there are in there. And since they're all the same size, if you're reaching in without looking, you can't know which one is which. So there are 20 bills, because 5 plus 15 is 20. So the probability of drawing a $1 bill, which is the probability of drawing a 1, is going to be 15 out of 20. Because there's 15 $1 bills and there's 20 bills altogether. Well, to find the probability of both of them happening, I need to take the probability of finding a $1 bill and multiply it by the probability of finding a $10 bill, based on the fact that we've already picked a $1 bill. Remember, we do that, but now that we've taken one out, now we only have 19 bills. Okay? There's still 5 $10 bills because I pulled a 1 out, so I still have 5, but now it's over 19 instead out of 20. So just multiply top, multiply denominator, and you will get 75 over 380. Now if you divide those two, you get like 0.1973 something, blah blah blah. So this is approximately 20% chance. So it's not great, but it's not too bad. right? Part B says, what's the probability of drawing two $10 bills in a row? Well, the probability of drawing a $10 bill at first, right, is going to be 5 out of 20. We're multiplied by the probability of drawing a $10 bill again. Well, now there's only 4 $10 bills left, and there's 19 bills left altogether. So again, just multiply, and you get 20 over 380, which is approximately a 5% chance. So it goes down dramatically for winning a $10 bill and a $10 bill. Now, another definition we need to talk about here is odds. It's slightly different than finding the probability, because notice the probability, you take the number of favorable and divide it by the number of possible, whereas odds is the ratio of favorable outcomes to unfavorable outcomes, and we use a colon there to express that. Alright, so this is like example 4. It says a box has 3 pink, 4 yellow, and 5 blue highlighters. 1 is chosen at random. So A, it says, what are the odds of choosing a yellow one? Well, the first thing we want to do is we want to talk about how many yellows there are. There's 4 yellows. So there's 4 favorable outcomes. And how many of them are not yellow or unfavorable? Well, there's 5 blue and 3 pink, so it's going to be 8 altogether. But of course we want to reduce that. That's going to be 1 to 2. So the odds are 1 to 2 in favor of you picking a yellow one. Part B says, what are the odds against choosing a blue one? So now we're talking about the ones we're seeing how many of them are not blue. Well, there's 3 pink and 4 yellow, so there's 7 of them that are not blue, and there's 5 of them that are. Because remember it says against choosing a blue. So what's the odds of choosing not a blue? So that is 5 to 7. Now one more I'm going to throw in here. It says, what's the probability of choosing a yellow? Well, the probability of choosing a yellow is 4 over how many other total? 8 plus 5, 13. Okay? Notice that's different than this one up here, because that's 1 to 2, and 4 to 13 is not 1 to 2. Okay, let's do one more. It says a computer club has 10 boys and 12 girls. The chess club has 15 boys and 5 girls. Each club will randomly choose a member to be the treasurer. What's the probability that both treasurers will be girls? Well, first of all, since each club is doing it independently, they're not going to be dependent. They're going to be independent. So we just need to find the probability of each one and multiply that. So first, let's do the computer club. There are 12 girls, and there are 22 members altogether, because I said the 10 plus the 12. That's the probability of the computer club. For the chess club, there are 5 girls and 20 members altogether, because I just said 15 and 5. Multiplying that, you get 60 over 440, which reduces to 6 over 44, or 3 over 22, which is approximately 14% chance that both of them would be chosen to be girls. Part B says both girls resign and a different pair of students is chosen. What is the probability that both treasurers will again be girls? Well, remember originally from the computer club we had 22, but one of them has already been picked and resigned, so now we only have 21 to choose from. And since that person was a girl, instead of being 12 girls to choose from, now we're going to only have 11. For the chess club, it's going to be similar. Now we only have 19 people to choose from. And before we had 5 girls, but now we only have 4 to choose from. So that's going to come out to be 44 over 319, which is approximately 11% chance of happening. Your homework is on page 208. You're doing all the 33s, all the 32s, and 5 more of your choice. Good luck.